So now in this video, we are going to see how to apply the k nearest neighbor on different kind of featureization. Fine. So now first we will see how to apply the KNN on Bagover's featureization, and also we will see how to do a hyperparameter tuning in order to find the best value of k in KNN. So basically we are having two methods to do this. The first one is using a simple for loop. So we choose this method when we are having some memory limitations on our system. And the second method we will see using the random search or the grid search that will take more computing power to run. So you can follow any one of those methods, depends on your choice. Okay. So now first we will see how to do a hyperparameter tuning using a simple for loop here. So before that we first initialize the function that you can see, that is batch underscore predict. So what basically the objective of this function we will see in a meanwhile, but before that let's move on to the code snippet here. So in this code we are importing some of the libraries such as PLT for plotting the graph, K-neighbors classifier for the KNN model, and ROC AUC score for the performance metric. And after this we are initializing two variables here, that is train underscore AUC and CV underscore AUC, where we are going to store the AUC value with respect to these two sets for the different values of k. And now in the third line we are initializing the different values of k in a list on which we want to perform tuning. So that using a simple for loop here, we are calling the function, we are calling our model k neighbors classifier, and within that we set the parameter number of neighbors is equal to I. That means we are passing each value of k in the list one by one. And also we mentioned here number of jobs is equal to -1. That means we want to use all the cores of our CPU in order to run the code faster. Fine. And now after initialization, we are doing the fit on your xtrain data and the corresponding ytrain. So basically in this line, we are doing the training on your train data. And now once the model is trained, in order to do the predictions, we are calling the above function, that is batch underscore predict, where we are passing our train model and the corresponding data set. So now let's try to understand that what we are basically doing in this function. So in this function, you can see that first thing is that for calculating the ROC AUC score, we need the two parameters. The first one is your ytrue, that means your actual class label or the ground truth value that contains either 1 or 0. And the second parameter we need the y score. So here instead of taking the predicted outputs, what we need is we need the probability value, or you can say the probability score for a point belongs to positive class. So here we also mentioned the same thing, that for calculating the ROC AUC score, the second parameter should be the probability estimate for a point belongs to positive class, not the predicted outputs. So that's why instead of using the predict function, we are using the predict underscore proba that will return you the probability values for a point belongs to particular class. Okay. And also as a name suggests here, batch underscore predict. So in this function we are doing a batch wise prediction with a batch size of 1000 so as to avoid your system getting stuck. So now let's take an example and try to understand that what we are basically doing inside this function. So now let's say your data here contains the number of data points, or you can say the number of rows 49,041. So now we have to calculate the probability score for each of these data points. So as a batch wise prediction, what we are doing, that first we are splitting your data, or we are dividing your data into different batches from the starting, each of size 1000. Okay. So how many batches you need? For that you have to simply divide this number with 1000 so as to get the number of batches. So if this number is not a multiple of 1000, is not a perfect multiple of 1000, then you will get a decimal value as a result that you can see here. So in order to make the math little bit simpler, what we are doing, we are first taking the last 1000 multiplier of this number, that is 49,000, so that when you divide this number with the 1000, you will get the integer value, or you can say a whole number, so that we can easily divide your data set into batches, each of size 1000. So here you can say that we need 49 batches, each of size 1000 here. So how you find? how to find the last 1000 multiplier of any number? Then you can see the line here that first we are taking data.shape 0. So data.shape 0 return the number of rows. So in our case we are having the number of rows is 49,041, and we are now subtracting this number by the remainder when this number is divided by 1000. So it will return you 41 as a remainder, so that when you subtract 41 from this, you will get the last 1000 multiplier of any given number, and we are storing that number in the variable this. Clear? So now you can see here that this for loop is now ranged from 0 till 49,000 with a batch size of 1000. So this for loop will iterate until the last 1000 multiplier. So in our case, you can say this for loop runs 49 times. And in the end, we are getting the probability score for the 49,000 data points using a batch-wise prediction. But actually, how many data points we are having initially? We are having 49,041. And using a batch-wise prediction with a batch size of 1000 using a simple for loop, we are now completed the prediction for the probability score till 49,000 data points. So how many data points we are now left with? We are left with 41 remaining data points. So for these remaining data points, we are now doing, you can see the code line codes these two lines, that first we are checking the remaining data points so that we can simply calculate the probability score using the predict_proba for the last data points, so as to get the probability score for all the data points in the data set in the end. Fine. So now one more thing here is that after the predict_proba, we are using square bracket colon comma 1. So why we are using this? Now let's see. So actually predict_proba, it will give you an array that contains the probability score for a point belongs to particular class. So in our case, we are having two classes. The first one is 1, that means the project is approved, that we consider as a positive class, and 0, that means project is not approved, that we consider as negative class. So predict_proba, it will give you a probability score for a point belongs to these two classes. So you can say that we are having 0.72 probability for a point belongs to class 1 and 0.27 probability for its beings to class 0. But in order to calculate the ROC-AUC score, we need only the probability value for a point belongs to positive class. So we need only this value, that is 0.72. So that's why in the end we are doing this so as to get the probability value for a point belongs to class 1. And also if you replace 1 with 0, that you can check your own, then you will get 0.27 as the probability. Understand? So now we are calling this function both for your trained data and also for your cross-validated data, so that we are getting the probability score with these two sets, and we are storing in a variable ytrain and yCV prediction. And now we are calling the ROC-AUC score, where we are passing the ground truth value and also the probability score, so that we can get the AUC score for each value of k that we are storing in a variable train_AUC and CV_AUC that we initialized here. So now using a simple plotting command, we can plot the graph here, where on the x-axis we have taken the different values of k, and on the y-axis we are having the AUC value. So this blue line is for your train AUC and this orange line in the graph is for CV-AUC. So now by looking at the graph, we have to find the value of k such that we are getting the maximum value of AUC on the CV curve. So you can see here that among these different values of k, this is a point, let's say here 101. So this is a point where we are getting the largest value of AUC as compared to any other value of k. And the second point here is that the gap between your train curve and the CV curve should be small. So here you can say that gap here is also small, and we are getting the maximum value of AUC with the value of k is 101. So you can conclude that using a simple for loop, we are getting the best value of k, or you can say the value of your hyperparameter k, 101. And one more thing you can see here, that this black bar, you can see this black bar. So using this black bar, we are simply checking the progress of your for loop. So how you are getting this progress bar? That we are getting using the TQDM function. Okay. So if you use the TQDM, then you can simply check the progress of your for loop. So here this for loop runs 5 times for each value of k. That's why here you can see the progress of your for loop and also the time per iteration. Understand? So now let's see the second method here, that is using the random search or the grid search. So here again, first we are importing some of the libraries that we are going to use in this code, and now we are calling the model k-neighbors classifier, and we again mentioned number of jobs equal to -1. So now in the second line we are initializing the parameters, that is number of neighbors in our case. So we want the number of neighbors in the range 50 to 100. And also since we are using the random search, so we want the value of k randomly between the range that you mentioned here. So that's why here we are using sp_randint, that will return an integer value randomly between the range 50 to 100. So now here we are calling the randomized search CV, where we are passing our model that we initialized here, and also the parameter, that is the number of neighbors, with CV is equal to 3. So here CV is equal to 3 means that we are using the k-fold cross validation with the value of k is 3. So if you are using either the random search or the grid search, then there is no need to split your data into cross validate. You can directly split your data into train and test using the train test split, because internally it will doing the cross validation using the k-fold cross validation technique. Fine. And also here you are seeing that we are doing the scoring ROC_AUC. So after the initialization, we are again doing the training on your train data and the corresponding Y-train, and the results what we got here is in the form of dictionary. So now we are getting the results from the dictionary and storing in a pandas data frame in the variable results, so that you can easily check for each value of your k-fold. You can simply see the mean and the standard train score as well as the test score in the table below. Fine. And again in the end, using a simple plotting command, you can plot the graph here as well. That is, on the x-axis we are taking the different values of k, and on the y-axis we are having the AUC value. So here again, by looking at the graph, you can find the best value of k such that we are getting the maximum value of AUC on the CV curve. So you can see here that these are the 2 points. Let's say this is a 0.62 and this is, let's say, 78. So you can see that these are the 2 points where we are getting the maximum value of AUC as compared to any other k point. But the second point is that the gap between your train curve and the CV curve should be small. So here you can see that for the k value 62, the gap is large as compared to the k value 78. Fine. So between these two values, you can say we found the best value of k as 78 using the random search. And using the for loop, you get 101. So it depends on the method you choose. Either you choose grid search or the random search, you may get the different values of the hyperparameter. Fine. So you choose the grid search or the random search if you are having the more computing power, because it will take more time to run. And also if you change or increase the value of CV, that is your k-fold value, then it will give you the more robust results. So in this notebook, we are just finding the best value of k using the for loop here. So we considering our value of your hyperparameter using the for loop, that is 101. So now in the next step, we will see, here we are going to see the testing with the tested data. So for that, here we are again calling the model, and now instead of the parameter number of neighbors, here we are giving the best value of k here, that is 101, and we are just doing the training on your train data. And after that, we are doing the batch wise prediction using the function batch_predict, and we are finding the probability score for your train and for your test that we are storing in these two variables. So now in the ROC_curve function, we are simply checking the AUC value, and we are getting the train FPR, train TPR, and also the threshold value with respect to your train and the test. And now we can simply plot the graph that you can see below, and simply check the train AUC that we are getting 62 and the test AUC we are getting 0.55. Fine. And on the x-axis we have taken the FPR, and on the y-axis we are taking the TPR, and this blue line is for your train AUC and this orange line is for your test AUC. So now let's see how to show the confusion matrix as well. So for the confusion matrix, we are again importing the confusion matrix from the scikit-learn library, and in order to plot the confusion matrix we need the two parameter. The first one is the actual class label that contains either 1 or 0, and in the predicted class, that is your y hat, here we also need the values such as 1 or 0, so that we can easily compare the values, so that we can, using a simple comparison, we can find the values of your confusion matrix such as false positive, false negative, true positive and true negative. Okay, but now what we are having the probability scores. So based on that, so we have to first find the threshold value so that we can easily convert your predicted class into 1 or 0, so that we can easily find the value of these 4 cells. Fine. So for that, here we are just writing our own function for finding the threshold. So we want to find the threshold such that our this term is maximum. So this term is maximum when your FPR is low and TPR is high. That means we want the best value of threshold such as your false positive rate should be low and the true positive rate should be high. And we are using the argmax here, we are finding the index of that number so that we can easily find the threshold, and we are storing in a variable t. So now in the second function what we are doing, we are first taking the probability scores from the data set and also the threshold value that we get from the above function. And now for each value in your probability score, we are checking whether this probability score is greater than equal to the threshold or not. If yes, then we are appending 1 in the prediction variable that we initialized here, otherwise 0. Okay, so that we can simply plot print the confusion matrix with your y-train or the y-test, doing with the best threshold value that you find, that you can see the results below. Fine. So now you can see here. Now let's move on to that description. So that description is that if your system is getting stuck when you are working with the KNN, then you need to use a batch-wise prediction. So here again we mentioned the same thing that you saw previously inside the function batch_predict. So here again we mentioned the simple pseudocode here, and also we provided some of the instruction, or you can say some good programming practice that everyone should follow, such as that you should read the documentation of the function so as to understand the meaning of the parameters, and also you should use as many print statements as possible so as to understand that what actually is happening inside your code. So you can just read these points later and just try to follow them. Fine. So now let's move on to another technique here. So now we will see that how to apply the KNN using average word-to-vec featureization. So for that, here we are using the GLOVE model, that is a pre-trained one. Okay. So simply here we are loading the GLOVE vectors that contains the vector representation for the word and storing in a variable GLOVE word. So now in this code, we are calculating the average word-to-vec for the feature assay in your trained data. Fine. So for that, first we are initializing the average word-to-vec vectors. We are going to store the average word-to-vec value for each row in your train. And now for each sentence in your train data, we are first initializing the vector of size 300. So you can change this value, okay, to any number, depends on your length that you want. So here we want each word represented by a word embedding of length 300. And also here we are calculating the number of words for each row. And now with this for loop we are doing that for each word in the sentence, we are finding whether that word is present in the GLOVE word or not. If yes, then we are simply getting the word embedding of that word, and also we are increasing the count for that row. And in the end, we are just dividing the vector by the number of words in that row, so that as to get the average word-to-vec for the first row. Fine. And also here we provided the description for each of these lines so that you can easily understand. And we also discussed this code with an example in the previous notebook so that you can easily follow from that. Fine. So in the end, you can see that the length of the average word-to-vec vector for the train we are getting 2244. That is the number of rows in your train data. And also the length for the first row we are getting 300, because now we are having a vector, or you can say each row is having a dimension of length 300. And also you can see the average vector vectors for the first row. You can simply see the word embedding of size 300 here. Fine. So the same that we did for the train, you have to do for the cross validate and for your test for the feature assay. So now here you can see that again we are concatenating the features. So instead of bagovers, now we are simply taking the average Vertu-Vec vectors for your assay feature, for your train, CVN test, and the rest of the features are the one hot encoding for your categorical value. So you can see that the final data matrix we are having now this much number of rows, and we are having 360 columns now to work with. So again we have to do the hyperparameter tuning. So here we are finding the hyperparameter tuning again with the for loop. So we just run the same code here, okay, and just plot the graph that you can see below and just find the best value of k here in that. So after finding the best value of k, again we are doing the testing with the test data. So for that we are just calling the k-neighbors classifier with the best k value that we found ever, and we are now doing the batch wise prediction using the above function, and we are finding the probability score for your train and the test, and we are simply getting the FPR and the TPR and the threshold value with respect to train and the test, and we are simply plotting the graph in the end that you can see here. Fine. And now based on the threshold value, we are again finding the best threshold value so as to we are getting the low value of your FPR and the high value of TPR. So that threshold value here we got 0.88, and based on that we are simply plotting your confusion matrix that you can see below, both for your train and the test. Okay.